Hello everyone, my name is Kingsley and I want to welcome you back to the video. In the previous video we looked at the concept of failover. We looked at the different ways and method we can use for failover of traffic between the primary and the secondary device, or node 1 and node 0 and node 1 as in this case. And so in this video the focus is going to be actual demonstration of those concepts that we discussed about. So we said for failover, which is the topic we want to cover, you have the manual method, okay, manual failover, and then you have the automatic failover. Okay, so it depends on if you've not watched the previous video. I think the previous video was the part 4, where we actually discussed the different in-depth, the different components of manual and automatic failover. Okay, so here we're just going to be demonstrating how we can actually implement manual failover, how we can implement automatic failover. We look at the triggers such as interface flaps. We're also going to look at power cycling the devices, and then we are going to look at how does it affect traffic from these servers to the internet. Okay, remember here we're just pinging 8.8.8. okay, so we're going to do continuous pinging from these servers, and then we're going to see how it's going to affect traffic between inside these two firewalls, where we'll move the traffic between the both nodes. Okay, remember in our topology we are only dealing with redundancy group 1 and redundancy group 0. Okay, so we're going to do failover for both group 0 and redundancy group 1. We're going to look at the best way to do failover so that it doesn't impact traffic. Okay, so that is really what we want to discuss in this session. Okay, so if you like this video, you want to like and also subscribe and also share with your friends, and so that when we come up with new videos in the future, you will be notified. Okay, yeah, so let's get started. So right now what we're going to do is these servers, right, we're going to do a continuous ping to 8.8.8, okay, which is this IP on the internet. I mean, it's the real IP, okay, because of course we are doing NAT on these two devices. So these servers, as they currently stand, they can reach the internet. So what we want to do is we're going to start with redundancy group 0. Okay, we're going to do a failover using the manual process because that's the first thing we want to talk about. So do failover for redundancy group 0. We'll look at the article. Then we also do for redundancy group 1. Okay, so that's where we need to start from. So I'm just going to bring up my console, which is this, so I can clean this out. Okay, so this is my console. And yes, okay, so these are the two servers. I already have a connection to them. If you do ifconfig, let me raise it up a bit, seems too big. ifconfig, you see the IP 10.0.0.20, and then for the second one, ifconfig, this is the 10.0.0. So this is the server, this is the server below here, server 2, and this one is for the server on the top. Okay, so here, as you can see, we should be able to ping the internet. So I'm going to do ping 8.8.8.8. so we have reachability to the internet, and here ping 8.8.8. okay, now the traffic should be going through the primary. We can check that by saying show chassis cluster status. Yeah, so as you can see, our cluster ID is 10. We've covered those in the past. So our focus here is the redundancy group 0. Okay, and for redundancy group 0, as you see it here, here is 200, okay, while node 1 is 100, okay. So that makes this is the primary and this is the secondary, okay. Yeah, so what we need to do now is we need to fail over the traffic from node 0 to node 1, okay, and then we're going to see what the impact will be on data traffic that goes to the internet. Is it going to impact traffic or not? Okay, so we'll see. Now the command to do the failover is very simple. It's request chassis cluster, right? It's a failover for redundancy group 0, and then you can say I want to move it to node 1. Okay, if you say node 0, it's going to say no, it's already node 0 is already the primary, so it's not going to work. Okay, so but we want to move it to node 1. Okay, so I'm going to hit enter. So the moment I hit enter, we'll quickly check the servers and see if there is an impact. Okay, so hit enter. So it's initiated. Let's see. Is there a break? Is there a break? There seems not to be any impact, right? There's no impact, and that is the expectation. Okay, that when you move redundancy group 0, which is technically the routing engine, it should not impact traffic because we are not even dealing with redundancy group 1, right? Redundancy group 1 is the redundancy group 1 is where you have the data traffic, right? But what we are dealing with now is redundancy group 0, which is actually where you have your routing table, all the processes are running. Now, if you look at this, you see that the moment we initiated it, there were some processes that immediately span up on node 1. Okay, these processes originally were not running, but the moment we moved the routing engine or redundancy group 0 from the primary to the secondary, you saw these logs popped out. Okay, things like periodic packet services, kernel replication, firewall, is a lot of services that just, right? So there are some services on the primary that got terminated, and then they automatically started up on the secondary firewall, as you can see here. But as we saw, there was really no impact on the customer traffic. Okay, now if I say show chassis cluster status, okay, now what do you see? Interesting. Now we have you see node 0 did not go to the secondary, but it stayed at what? Secondary hold. Okay, now this secondary hold is referring to the hold down timer that we talked about in the previous video, right? The hold down timer basically is a dampening mechanism, right? It's a dampening mechanism implemented by Juniper to ensure stability of each redundancy group. Okay, now we said that for redundancy group 0, the default value is what? 300 seconds, which translates to 5 minutes. Okay, and we also said that it really depends. If after 5 minutes the services are still not ready, okay, what happens is the system will continue to extend it by additional what? 60 seconds. Okay, so this is the 5 minutes is really the minimum. Okay, in most cases you can have it, it can be in this state for more than 5 minutes, even if 5 minutes is the minimum value that is set there, right? Okay, and I also said in the previous video that the range is between what? 300 seconds, right, to 1800 seconds. I think we said this translates to about 30 minutes, right? So when you do a failover from the node 0 to node 1, then this hold down timer is going to kick in, right? So what that means is you can no longer move it from node 0 back to node 1. I mean from node 1 back to node 0 until this timer expires. Okay? Until the system is fully ready, you cannot move the traffic back to node 0. Now something else you also need to notice is that look at the priority here for node 1. it automatically moves to the highest, which is what? 255. Okay? So the moment you do that manual request, you initiate the failover from node 0 to node 1. Node 1 automatically sets its priority to the highest value. Okay? Now, if you need to, right? If you need to move the traffic back to node 0, you will need to reset this value. Okay? You will need to reset this value before the traffic can move back to node 0. Okay? Now, for redundancy group 0, it's still different. Even when you do the reset, okay? Yes, when you do the reset, it's going to normalize the values such that node 0 becomes 200, which is the configured value. This is node 0. And then node 1 remains as 100. Okay? So even when you normalize these values to the configured value, it doesn't mean that the control plane or the routing engines automatically move from node 1 back to node 0. No, it's still going to remain here. Okay? In most cases, you will need to manually request that the traffic move back to node 0. Okay? Or maybe on this device, there's a power cycle, it's power cycled. Okay? Or maybe it's lost, it went down due to power or any other reason. That's only when the routing engine automatically, as soon as node 0 detects it, automatically it's going to go primary. Okay? So let's take note of that. So I think even from our discussion, it's been up to 5 minutes. So we'll run the command again and see if it has gone through if the hold down timer have not expired. So I'm going to run it again. You see it has not expired. Like we said, it could take a while. Okay. Now I'm going to do show chassis cluster interfaces. Okay. We'll come back to this. Here we've already talked about this. You have the control link, then you also have the fabric link. Okay, you have your rect interfaces. We'll come back to this and look at it again in details. Okay, now the second question is, while this is baking, right, while we have the hold down timer still running, can you move redundancy group 1 from node 0, right, to node 1? That's the question. Well, it's not advisable, but we are going to do it here and we're going to look at what will be the impact. Okay? But I believe the best practice is when you move redundancy group 0, you need to give it you need to give it time to stabilize, to move back into that readiness state. Okay? To say, okay, I'm ready, and everything is running, the system is stable before you move redundancy group 1. Okay, now if we try to move it, okay, if we try to move redundancy group 1 while redundancy group 0 is not ready, it could also lead to impact on your data traffic. Okay, so the advice is don't be in a hurry, just give it time for this secondary hold down time to move back to secondary before moving the redundancy group 1. Okay, but the question is, does it mean node 1 is not forwarding traffic? It is, right? It is. So using the secondary hold does not necessarily mean the system is not ready. Okay, what the secondary hold is really doing is preventing you, or preventing the system itself from moving from node 1 back to node 0. Okay, so I don't believe it's because the routing engine, or when you move failover to node 1, it's because it's the processes are still running, still trying to come up. Because if there was an issue with the node 1, I don't think the data traffic would have been going through, right? So let's just try it. What we're going to do now is we're going to go to redundancy group 1, and we're also going to failover from node 0 to node 1 while this whole time is still running, and we're going to see if there will be impact. Okay, so let's do that. I'm going to say request chassis cluster failover, right? This time redundancy group 1, and then we want to move it to node 1. Okay, so I'm going to just hit enter. So there's a failover. Let's see. Yes. So as you can see, there's drops. Okay, there's drops, but it's back up. Although this does not show the number of packet loss that you experienced, but at least we noticed that there was a drop. Okay. Now, this drop that you experience is not in any way related to what is happening in redundancy group 0. No, they are completely isolated. Okay, they are completely isolated. So when you move between redundancy group for a data redundancy group, like from 1 to 128, you should expect some few drops. Okay, so it means if you are working in a delay sensitive environment, you might want to do this outside peak hours. Okay, you have to have like a scheduled maintenance where you have the least impact. Okay, now if we look at show chassis cluster status, you see that this automatically moved from primary to secondary. The hold on time was not there. What is the reason? But you see the value is now what? It's also 255, right? The value is still 255 the moment we moved it to node 1, and we see that this node 0 transition directly from primary to secondary. Remember, we said that for non-redundancy group 0 redundancy groups, right? So for let me grab my pen. So for redundancy group 1, remember the default hold down timer is what? Is 1 second. Okay, so even before you blink your eye, it has already gone past the hold down timer, and you know the traffic has already moved over, and then the hold down timer have expired, so it transitioned from primary straight to the secondary. So that's why you don't see it here. Then of course the redundancy group 0, you see, I believe it's been more than 5 minutes now, and it has still not converged, if I want to use that word. Now, let's say we want to fail over this redundancy group 1 back from node 1 to node 0. Okay, so let's do that. I'm going to say request chassis cluster, right, failover redundancy group 1, right, to node 0. Now it's going to throw us an error. So the first thing it's going to tell us is that redundancy group 1 was already manually, there was a manual failover already, right? That's what this is saying. Okay, so there was already a manual failover. You say, please, you have to do a reset first. Okay, so we need to normalize these values first to the configured values before we can do the failover. Okay, so that's what we are going to do. And what I also want us to do is, I want us to increase the hold down timer to maybe, let's say, 2 minutes. Okay, so I'm going to set the hold down timer for redundancy group 1, the hold down timer, right? I'm going to set this value to 2 minutes. Okay, 2 minutes, I think it should be like maybe around 50 seconds or something. Or no, sorry, 2 minutes 6 is 120 seconds. Okay, 120 seconds. Okay, so we're going to set it to 120 seconds. And then we'll see when we do the failover, you see that node 1 will have to stay in a secondary hold down state for a while. Okay, so let's do that. So here, let's normalize first. I'm going to say request chassis cluster redundancy failover, right? I'm going to say reset redundancy group 1. Okay, so there's a reset. So if we say show chassis cluster status, you see the values are now the configured values. Okay, which is here, which is 200 and 100. Okay, now let's set the hold on timer to be 20 minutes. 120 seconds. Okay, so I'll go to edit mode and say set chassis cluster. Okay, we'll see redundancy group 1, you call it hold down interval. Okay, the hold down interval we want to say should be 120 seconds. Okay, so we'll hit commit and then quit. So this is going to apply to both nodes. And then when we say request chassis cluster for redundancy group request chassis cluster failover, right, for redundancy redundancy group 1, we want to fail it back to node 0. So it's going to move back to node 0, right? Oh, it has already moved. It seems it has already moved when we initiated it, even though it showed us a warning. Okay. Okay, I know what the problem is. Okay, so if I say show chassis cluster status, now redundancy group 1, how do I put it, works differently from redundancy group 0. Okay, now the moment you normalize these values, let me grab my pen. Okay, so the moment you normalize this value by doing the reset, give me this. By doing the reset, okay, what happens is, because this value changed from 255 to 100, what happened is they compare their priorities. Oh, no, 0 is going to say, well, there was a reset and I have higher priority than you. So the traffic automatically moved back to node 0. And I believe the traffic has already moved down before we configure the hold down timer. Okay, that's why we did not see node 1 transition to secondary hold state before moving to the primary. Okay, so what we will only try to do now is we are going to move the traffic from node 0 back to node 1, so we can just see how that hold down timer we keep node 0 on hold down or standby for that period, for that intervals, right? So it means for the period of the hold down timer, you cannot fill traffic back to node 0. Okay, so let's do that. Now, while we were discussing, we'll see that node redundancy group 0 has now finally converged, right? So the value it has now moved from the secondary hold down state down to the secondary. And I bet you it was more than 10 minutes or even 15 minutes. So it really depends on, of course, these are virtual devices, so we can, but if they were physical hardware, I believe it would have been shorter. You would have had convergence quicker. So, but please note that whenever you move the redundancy group 0 from one node to the other, there's always the hold down timer that kicks in, and until that hold down timer expires, right? And until the systems feel it's ready, that's when that value goes away. Okay, so now I'm going to delete this, then I'm going to say show chassis cluster, not show chassis, so I'm going to say request chassis cluster failover. Then we're going to say redundancy group 1. Let's say we want to move it to node 1. Okay, so if you now say show chassis cluster status, so you see we are now able to catch this secondary hold down time. Okay, so it's now, so it will be here for about what, for 120 seconds, for about 2 minutes. Okay, before it's finally moved back. So the implication of that is that if we go back now and we are now trying to fill the traffic back to node. So let's do it again. So we need to do, let's see if we will do a reset, is it going to take it? So let's do a reset again. There's a reset, but let's now say show chassis cluster status. You see, because until the hold down timer expires, even when you do a reset, it will not automatically fill back. Okay, it will not automatically fill back. And when you try to do manual failover, let's say move back to node 0. Let's see what it's going to tell us. It's going to say manual failover is not permitted as readiness check failed. Redundancy group 1 or 0 is in a secondary hold state. Okay, well, you see, if you want to force it, right, you can use the force option at the end of the ignore this check. Warning, using force may cause traffic loss. Okay, so from what I understand, right, this hold down state does not necessarily mean that, oh, there are some processes that were still on the device that are still not up, or there's still something. No, it's just a timer. It's just a way of, making sure both nodes are stable. You don't have frequent, traffic moving between both devices. That's just what the hold timer is. Same applies to redundancy group 0. It doesn't mean when you move traffic, when you move the routing engine from node 0 to node 1, oh, there are a lot of things that have to happen. Yes, it's possible, right? But this hold timer is just a timer that is running. You understand? And when it expires for redundancy group 0, if the system detects that, oh, they are not yet ready, or it's not yet stable, then it will on its own extend the value by what? 60 seconds. Okay, so I believe we should have exceeded our, yeah. So now the traffic have moved back to node 0 because we did a reset. But you see the secondary, now the time interval is there's a countdown again on node 1. I believe with the way we have demonstrated it now, it's very clear how the hold down timer works. Yeah, so that's the how you do manual failover. I believe we've covered every aspect of the manual failover, both for the routing engine and also for non-redundancy group 1. The next thing we need to do now is to do the automatic failover. Okay, now we did say that for automatic failover, I'll put it here, automatic failover, it could be as a result of different reasons, right? Number one is things related to hardware, things related to software issues on both devices. For example, if you stop receiving heartbeats from your peer, right? Hardware related issue could be, power loss, power loss, okay, that cause the device to go off. Okay, software could be some processes that are stuck or hang or due to bug, or could be any reason, right? And then if we start monitoring the interface, it could also be as a result of interface status, okay, such as down/up. Okay, it could also be IP that becomes unreachable. There's something called the IP monitoring, which I believe we'll cover in the next video, right? So if you're monitoring an IP, let's say our gateway, which is 192.168.1.1, let's say this IP becomes unreachable, it's going to cause the firewall to fail over. That is, we'll discuss this in detail, so let's not dive too deep, okay? So these are some of the reasons. So what we can just do, of course, here we cannot demonstrate this, except we have to go into the Linux share and shut some processes down. I have no idea what processes you want to shut down. Okay, so we're just going to ignore that. But what we can do now is we are going to try to power cycle, right? We'll power cycle one of the node, and then we'll see what happens. Okay, the moment you power cycle, you see what happens. We are going to look at scenarios. We'll see what happens on redundancy group 0, and we'll also look at the behavior in redundancy group 1, because the behavior is quite different. Okay, when there's hardware failure, and let's say the device power cycle, maybe the PDU in the DC has issue, and that PDU, the first device was connected and it lost power. So we're going to see what is the difference when they both lose power and then they come back online, come back up. What happens between redundancy group 1 and redundancy group 0? Okay, so that's what we need to quickly cover here now. Okay, so what I can do here now is so let's see the current status. Show chassis cluster status. Okay, so we know that node okay, so first thing I'm going to do is I'm going to move redundancy group 0 back to node 0. Okay, so I'm going to make node 0, let's make him the primary, and then before we do the power cycle, so I'm going to say request chassis cluster status, no status, request chassis status, then failover, right, for redundancy group 0. So we want to move it back to node 0. So that is done. We can then do a reset. We might not be able to do, yes, we can do a reset. So let's say request chassis cluster failover reset for redundancy group 0. Okay, that is done. And then we can say show chassis cluster status. So we should see it did what did I do? Let's see, let's go back again. Yeah, we did a failover. So yes, so let's say show chassis cluster status. Did it not move? Yeah, so now it has moved. Okay, so now it has moved. What now happens if we do a reset? Let's see. Okay, no reset required. Yeah, so let's look at it again. Oh, maybe I think we probably missed something. I don't know. Okay, so yes, we've moved the traffic back to node to the primary, which is node 0 for both redundancy group 1 and redundancy group 0. We know this device is in the hold down state, and I think we need to hold down. So I'm just going to pause the video a little bit, right? And then we'll come back. So once this is now in the secondary state, then before we do the power cycling. Okay.